Good morning, folks. Today we shall be moving on from the horror that was the malted milk, and we shall be going on to a good solid biscuit, the good old milk chocolate digestive. And we shall be building on what we did last time, which was simply find the area under a curve. Now we're going to be looking at the area under the axis whenever a curve drops below the axis. It's very, very similar. So it's very, as long as you manage to do what we did yesterday, this shouldn't be too tricky. There's only one little thing to think about. Right, first little mass factoid for you to write down is here. When the area bounded by a curve in the x-axis is below the x-axis, the integral will give us a negative answer. Copy that down and think about what that means. Here's our first example, and whilst you're writing that down, I'll just share with you my thoughts on the chocolate digestive. Now, they're always slightly disappointing. I always think they're going to be better than they are. I do find eating them upside down helps, so you get the chocolate straight on your tongue. But anyway, whatever you prefer. Right, having a look at this then, y equals x, and we've got it in a bracket. The first thing I would do is expand the bracket so you can think about it as x squared minus 3x, although with it in its bracket form that helps us think about what the sketch is going to look like. Now it's x squared, so we know it's a happy smile, and if there's my y-axis, x equals 0 will be one of the roots, won't it? And the other one will be, to make that bracket equal to 0, would be positive 3. So we would be looking at 0 there, and if that's 3, putting some kind of a curve in like that. Oh, not a very good sketch, but never mind. And what we're looking at is the area of this. Now we're going to do the same thing as we would do normally, but we're going to be given a negative answer, and then we just take away the negative to say how big that area is. So what does that look like? Well, if we start off by saying, right, we're going to want it between 3 and 0, and it's x squared take 3x dx. Moving that on, if we integrate that, that's going to say, right, nice big square bracket, up the power to 3, divide by the power, up the power to 2, divide by the power, gives us minus 3 over 2x squared, and that is all going to be done between x values of 3 and 0. So now all we have to do is substitute x equals 3 and x equals 0. So to do that, you may want to pause it and have a quick go and see if you get it before I do. That's going to give us 3 cubed over 3 minus 3 over 2 times 3 squared, which we know is 9. And then if all of those are 0, that's going to give us 0 minus 0, which is 0, isn't it? So looking at that, that's just going to give me 27 over 3 is 9, minus, this is 9, isn't it? 9 times 3 is 27 over 2. So 9 minus 27 over 2, which you can work out as being 18 over 2, gives us minus 9 over 2. You can smack that in your calculator as well if you want to. What's happened to my pen? Very naughty pen. Right, minus 9 over 2, which is 4.5, isn't it? But we don't want it as a negative value. We want to know how big that area is. So the area is 4.5 square units, although you don't have to write that, but I just like to. Okay, and that's the first example. One more to come, folks. Here's our second one, and this is a cubic if you look there. Now before you go any further, copy it down, and I'd like you to see if you can write down what the roots are, where it's going to cross the x-axis before you go any further. So hopefully the roots that you should have are x equals 0, because you've just got the x on its own there. So if that was 0, that would make that whole expression equal to 0, wouldn't it? And then for that bracket, plus 1, so x equals 1, and also negative 3 plus 3 makes 0, so negative 3 there. And what that means is we're going to be able to make a sketch with our y-axis and our x-axis, and we know that it's going to go through 0, it's going to go through 1, but I'm going to make that a little bit bigger, that, and then negative 3, so that's 1. Let's go back a little further here. Negative 3. Now exactly which is it doing, that or is it going the other way around? It's going to be positive x cubed, so it should be doing that, but always a good idea to check. So just get the calculator out and whack that in, press draw, and it gets us something that looks a bit like that. So that's what we're sketching in here. Coming up and then going down and up again. And what we're wanting to do here is to find this area, but also this area here. Now what we can't do is just say I want it between x value 1 and x value negative 3. And the reason for that is it's going to give us a positive area here and a negative area here. So it will actually give us the area of this amount, take away that amount, which we don't want. We need to add these two areas together. So in order to get that, we're going to have to do two separate substitutions. We're going to need to find it for between negative 3 and 0 and between 1 and 0. First thing to do though is integrate. So have a go at expanding the brackets and then see if you can integrate it. Pause the video and we'll carry on. So first up, you should have expanded it to give that and say, right, I want to integrate for this area. I've called this area area A, between 0 and negative 3, between 0 and 3, x cubed plus 2x squared minus 3x. In order to get that, I expanded the first part and then just used a little grid to expand the rest of it. Okay, and then you need to break out the square bracket, and we're saying we are going to be, so integrating that will go up to 4, so that's over 4. This one's going to go up to a 3, so the 2 divided by 3, and we're going up to x squared, so the 3 divided by 2, and that's going to be between 0 and, oh, I put positive 3 there, didn't I? That should be a negative 3. So, see if you can expand that, pause it, and then carry on. We have the first part, all of this is going to be worth 0, isn't it? And then we're going to be taking away from that what we get for negative 3, which will be negative 3 to the power 4 over 4 plus 2/3 negative 3 cubed, take away 3 over 2 negative 3 squared. You could either work that out manually or pop it all in the calculator, and when so all that in the calculator, putting brackets in there to make sure of what's going on, should give you 45 over 4, and that's area A. So then for area B, you need to do the same thing between 1 and 0. Have a little go at that, pause it, and then we'll see if you agree with me. So that should have given you -7/12. If we put 1 in for all of those, it's very simple, isn't it? You just, all the powers disappear in effect and you just get those fractions. Add them together gives you -7/12. A 0 gives you nothing. So area under there, -7/12. Therefore, the area B is going to be that positive value. And so the total area is going to be area A, which is 45/4, plus area B, which is 7/12. And all you have to do, add those together, gives you 71/6, which you can leave as a mixed number or whatever, but that'll do. That's absolutely fine. As an answer, you can say units squared if you like, but that's that. Right, and so in order to practice, that's just 3 questions in exercise 13F. I'd like you to do all of those, and if you find that that's gone quite quickly, quite easily, or you want a bit more of a stretch, if you have a look at the challenge underneath that, there's a couple of questions there. That goes on for quite a bit, so by all means, have a go at the challenge. If you've got any questions about it, please email me as normal. Okay, cheerio, folks.